Okay, this is 8F2, 8th grade functions, standard 2 video to comparing functions, linear equations in two variables. Here are a few terms to know. I'd like you to copy these down in your journals and define them if you haven't already. Some of these I think we've already done on another flip chart. The first part of this says, let's check our solutions. Tell whether the ordered pair is a solution of 3x plus 2y equals -8. So in the standard, they're talking about this equation, linear equation in two variables. And the two variables in this equation have to happen to be x and y. Now, if we have a series of ordered pairs, such as x and y, they will create a straight line. These variables have an exponent of 1, x to the first power and y to the first power, and that is what is going to create the linearity or the straight line for us. Now, what they want us to do here is they want us to check each of these ordered pairs separately and see whether or not it is actually on this particular line that we started with. So this is a basic substitution problem. We're going to take our equation and substitute in the x for the x variable. So if x is 0 and the y is 4, is that going to equal -8? So 3 times 0 is 0. 2 times 4 is 8. Is 8 equal to -8? Let's see, is 8 equal to -8? So this is no. Not a solution. The ordered pair 0, 4 will not be on the line when we graph 3x plus 2y equals -8. And later on in this video, we're going to be graphing these awkward looking equations. So we'll substitute again. Let's just check this particular point. This is practice, substituting in variables and solving mathematically. So here we go, 3x. 3 times x plus 2 times y. Y is -1. Is that going to equal -8 after I do all of my math? So 3 times -2 is -6. Positive 2 times -1 is -2. Is that equal? Okay. I lost $6 and then I lost 2 more, so I have lost $8. And yes, this is a solution to the equation. This ordered pair will be on my line 3x plus 2y equals -8 when I graph it. All right, last one again, just practice. They picked out some random ordered pairs. 3 times x plus, it's right here in my equation, plus 2 times -12, is that equal to -8? 3 times 4 is 12. Positive 2 times -12 is -24. Is that equal? 12 minus 24 is -12. So this is not a solution. It will not be on our line. All right, now they would like us to take this equation, which happens to also have two variables in it, both of them to the first power, y to the first and -x to the first. And we have to tell, after we graph it, we have to tell whether or not this is a function. Now we have talked at length about what a function is according to the standard. That would be for each input x, it will have one and only one output y value. Now there's a couple of different ways that we can do this. I can create a function table and make up a bunch of x values, our inputs, so what I put into the equation. I just pick some random values. What I put in, I'm going to follow the equation and it will tell me what I'm going to have come out. So that would be my output. If I have x being -2, I am substituting into my equation a -2. So if I have a -2, my output would have to be +2. So when my input is -2, my output is +2. All right, let's try another one. If my input is -1, I'm going to have a negative x, so my -1 will come out to be a +1 output. 0, well, we don't have a -0. We don't have a +0. 0 is just plain old 0, so that doesn't change. Now my input is +1. So if I'm following my equation, a negative, and then I put my input in, I created an input of 1, and that is going to spit out a -1. And now I have a +2 that I inputted, so -x, my x, I want it to be a +2. I now have a -2. I can go to my coordinate plane and I will graph all of these ordered pairs, and these are all solutions of the equation. They will create the equation and they will all work as we just tested. So let's go to our graph and graph all those points. So we have -2, 2, -1, 1. So we go -2, 2, -1, 1. The origin 0, 0. We're going to have 1, -1, 2, -2, and I think you can see the pattern. 3, -3, all the way down, and all the way up. We take out our straight edge, and we graph a nice straight line through the grid, connecting all of our points. And now I can, let's just clear out those annotations there. So there is the line that we call, let's give it a name, y is equal to -x. All right, the second way, I said there are multiple ways of graphing this line. The second way would be to use our slope-intercept form that we have learned to be called mx plus b. So y is equal to mx plus b. B is known as the y-intercept, and that is where the line will be crossing the y-axis. And the m right there is known as our rise over run, also known as the slope. And in the last video, we talked a lot about the rise over the run. And we've also learned that x and y are all of your solutions that we will be substituting in, and they will be the ordered pairs that generate the line. Now, if I'm looking at y equaling mx plus b, I see that I have y equaling -1x plus 0. I don't have a b, it's missing, so I call this 0. Now if I were to go graph this again, and I have y equaling mx plus b, my y-intercept is known as the origin because I have a 0 here. So I will begin graphing on my y-axis, my y-intercept at 0. And then I need my rise over run. And the rise over run says -1 And in order to keep it a negative slope, I know that I need to divide by a positive. Now, if this is my rise in the top and my run in the bottom, I know that I'm going to rise -1. So this is my y-axis. Rising -1 means go down 1 on the y-axis and then right 1 on my run. Down 1, right 1, down 1, right 1. And I can keep going. And then to get the upper portion of our line, we know that the fraction +1 over -1, that's still a -1 slope when I simplify it. That means go back to the y-intercept where we began, where it crosses the y-axis, and we rise 1 and run to the left 1, right? So we have rise positive and go to the left run 1 time. Up and over, up. And as you see, we have the exact same line graphed in 2 different ways. Okay, pause the video, grab a piece of graph paper, and I'd like you to graph this in both ways. So use the function table and then check your work with the using the visual idea of the y-intercept and your slope. So pause the video. Okay, we are back. I hope you generated this function table. I like to choose some simple values. I like to keep it small, so I would be grabbing these values. You can pick anything you like, and it will spit out your outputs. And for time purposes, I'm going to use the visual method. I'm going to be graphing using the y-intercept and my rise over run. So I will be starting on the y-axis at -3. I'll put a dot at -3, and then I will be, from this point, I'll be using my slope. My rise is 2. It's a positive slope, so I'll have a +1. So let's go do that on a grid. My starting point, we said, was our B, 1 to -3, and my rise over run was 2 over 1. So that means rise 2, run 1, rise 2, run 1, rise 2, run 1. Fall downward 2, go backward 1. So the other side of this will be -2 over -1, and both of them get a simplified answer of +2. Okay, get your straight edge and run your line right through those purple dots, and we should have similar answers. All right, last part. Before we can do any of that fun graphing and using function tables, it is easiest to put equations into slope-intercept form. I guess we can write that up here. Let's find a spot. Slope-intercept form. And you remember that as y equaling mx and your b. Now the b can be positive or negative. Adding is the opposite of subtracting. So we could have plus b or minus b. So I'd like to start with the equal sign. I'm going to stabilize my y. It's on the left side. I'm going to keep it on the left side. I have this -1x term. I know I need the x over on the right side, so anytime we take a whole term and put it on the other side, it changes sign. So it was negative, it becomes +x. And here is our b. This is our constant term. It was on the right. I need it on the right, so I'm going to keep it as it is. I'm not going to change its sign because I didn't relocate it to the other side of the equal sign. Okay, next one. Equal sign. I see my positive y on the left. I'm going to keep it. Again, I see this 2x. I need to get it over to the other side, so I'm going to change the sign of it. And then I have a 1 on the right. I'm going to keep it 1 on the right. Now the last one, there's an additional step. I see that there's a -2 attached to the y. I'll take care of that in a minute. But let's stabilize that -2y. I've got my equal sign. I have to take my 5x, throw it to the other side, so I'm in slope-intercept form. So 5x to the other side is -5x, keeping my 6 on the right. And since I need a 1y on the left, and I have a -2 right now, we know to use the inverse operation of multiplication, which is division, and everybody gets divided by that -2. That coefficient that's touching the y, we need to undo that. So now we have y equaling -5 over -2x. Positive 6 divided by -2 is -3. And we will be simplifying a negative over a negative. So let's do that right now. Y equals positive 5 halves x minus 3. And there's your rise over the run. And there is your y-intercept, your starting point on the y-axis. Wow, that was a lot. I would like you to, in your journal, define the given terms on page 2 of the flip chart. I'd like you to write a few sentences on what you've learned from this video. If you have any questions, please write them down, and we are going to be practicing these problems when you get back to class.